Alright, hi everybody. I just want to give you a quick little video, some more writing transformations. This time we're going to focus on quadratic functions. All of your old rules do apply for quadratic functions, and all of your old rules for transformations are going to apply also, and we're just going to kind of combine them. And so in today's video I want to talk to you about what a vertex is, what vertex form of a quadratic function is. You've actually already seen this. And then also talk about transformations, not only a transformation of the parent function, but also a transformation of a different function, and kind of give you some shortcuts and combine some things of what we've already done. Okay? So let's start with the definition of a vertex. A vertex, real simple. It's the lowest point of a parabola that opens up, or it's the highest point of a parabola that opens down. So the lowest point of a parabola that opens up. And remember what a parabola is. A parabola is the graph of a quadratic function. Okay? And let's put this other part in here. The highest point of a parabola that opens down. Okay? So let's look at it graphically. So the first one, lowest point of parabola that opens up. Let's go ahead and draw a parabola the best you can. Remember, it's that general shape. And then here's our lowest point right about there. That's our vertex. And then if you have one that opens this way, I would say the vertex is right about there. Okay? So that's what a vertex is. Now, how do we figure out the coordinates of the vertex? And you can do it actually from a quadratic function. If you have this form right here, which is the form that we have already discussed. So it's f of x equals a times the quantity x minus h squared plus k. Now, where is the vertex? The vertex is h comma k. So that means that if I just throw out a quick example here, let's say I have f of x equals 2 times x plus 4 minus 3. Your vertex, notice how it's x minus h, but we got a plus in here. Notice they're opposite. The vertex is going to be negative 4, and then see how we got a minus 3? Minus 3. So the k value, the y coordinate of the vertex, stays the same, negative, negative. The x value, the h, notice how it's opposite. That's always going to be true. Okay? So that's just a real quick concept about what a vertex is. If you have this form of your equation, how do you find the vertex? And we'll, of course, look at other versions and other methods to find the vertex also. All right, so let's take a look at these two examples. The first example is we want to do some transformations of the parent function of x squared. So we got let the graph of g be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph f of x equals x squared. Then we're going to identify the vertex. So stuff we've done before, table right here. So make sure you have that available moving forward with everything. All right, so what are we doing in this function here? I'm going to get out my highlighter. And so what all is happening? We've got a vertical stretch of 2. That's one thing that's happening. We've got a reflection in the x-axis. That's another thing that's happening. And we also have a translation 3 units down. So let me mark that up in a third. All right, so what do each of those look like in terms of this page right here? So if we have a vertical stretch, if you remember, a vertical stretch was always the a value times whatever our function was. and we have a vertical stretch of 2. So really what we're going to do is we're going to take the function and we're going to multiply it by 2. And that's what's happening there in the blue. So let me Bob Ross this up. Happy trees, happy trees. Maybe put a little mountain in the back, you know, a tree, just whatever you feel like. All right, reflection in the x-axis. Remember reflection in the x-axis. That is taking your function and multiplying it by -1. Okay? And there's really nothing special about that. There's no a value or anything like that to fill in, a or k or h. So that's the second thing. So that's what we're doing there in the pretty pink, my least favorite Molly Ringwald movie. Ask your parents, they'll get that joke. All right, last thing, translation 3 units down. So what does that mean? That means we take our function and we subtract k. In this case, we're going to subtract it 3. And that is our orange. All right, so now why did I write these things down? Basically, I wrote these down so that you can take all 3 of these different transformations and combine them into one sort of equation. And I'm using air quotes. Equation, quote unquote. And then we can do some substitution, and our final thing will be a g of x. So what do I mean by combining these into one sort of equation? Well, if you look here, I've got 2 times my function, and I've got -1 times my function. Because we're going to be multiplying both of these times our function, we can combine them. And we have 2 times our function. Okay? Also, if you notice, we're going to take our function and we're going to subtract 3 for this translation 3 units down. So what I can do down here when I'm combining everything is just put a -3. So this is what g of x is going to be equal to. The only thing we have left to do is to get rid of f of x and replace it with x squared. Because we don't want f of x here, we want like an actual variable. Okay? And since we know that f of x equals x squared, what I can do at this point is I can take x squared and I can plug it in for f of x since they're equal to each other. So a little bit different form of substitution than what we're used to. So our final answer is going to be g of x times -2 times x squared minus 3. Or if I want to get just kind of write it cleaner, g of x equals -2x squared minus 3. So that's a cleaner version of it. So this is the function g. I've got a vertical stretch by a factor of 2. That's this 2 right here. I've got a reflection in the x-axis. That's the negative. And I've got it moved 3 units down. All right? So that's the whole idea there. All right, the next part of this problem, it says you want to identify the vertex. So what we have to do in order to identify the vertex is we have to write it in this form. And you can see we're pretty close. We already got an a value of -2. We've already got a plus k. In this case, it's a minus k. It's a -3. But what we don't have is an x minus h inside the parentheses. So what we need to do is we need to manipulate this in such a way that we do not change the overall value. Well, the best way to manipulate it so we don't change the overall value is to subtract 0, because x minus 0 is the same thing as x. And then we can go -3. What does this tell us now? This tells us our vertex is at 0, -3. Okay? So 2 things in this problem. The first thing, the idea of taking all of your transformations, and combining them into one, okay? And then doing the necessary substitution. In this case, we already have f of x, so we got to substitute in the other side of it, x squared. And then rewriting it so that we end up with vertex form. All right, this problem is very similar to what we did up here. So let's go through this. So let the graph of G be a translation 3 units right. So there's one thing that I'm going to do. And 2 units up. So it's a translation 2 units up. There's the second thing I'm going to do. And then a reflection in the y-axis. Right there. Of that graph. So let's do what we did over here. And let's write everything out. So let's see. We got a translation of 3 units right. So remember, to move right is an x minus h. In this case, we're going to subtract 3. So that is the blue. 3 units to the right. All right, the second part, 2 units up. So that takes our function, and we add k. In this case, k is going to be 2. So that is our Molly Ringwald part, pink. A lot of people like Ducky, not a fan. All right. Oh, that's actually orange. Let's redo that. Oh boy. Too worried about movies. All right, so that's the 2 units up. There. All right, looks mostly orange. All right, and lastly, reflection of the y in the y-axis. So reflection in the y-axis, if you remember, is we put in a negative x in place of x. And there's nothing special for that one. That one is the Molly Ringwald, pretty in pink. All right, Breakfast Club was better. Okay, so now let's combine all of those things. So what do we got? Notice how we've got x minus 3 on the inside, and we've got a negative x on the inside also. We can combine those. So g of x is going to be negative x minus 3, like that. Okay, we can make the x negative, and then we also have the subtraction of 3. And then see this plus 2? This goes outside here. And so this is our total transformation. Now, we're going to apply it to this function right here. So, kind of put this off to the side. F of x equals x squared minus 5x. So what that means is I have to take this negative x minus 3. I need to plug it in there. I need to plug it in there. And then I have to, at the very end, just add 2. So it's going to look like this. So I plug negative x minus 3 in for x squared. So it's going to be negative x minus 3, the quantity squared, minus 5 times negative x minus 3. And so that replaces that x. So this right here is replaced by these 2 lines right here, these 2 terms, and then I still have to bring on my plus 2. All right, all this stuff is the evaluating functions stuff we did on Tuesday. So I got to do magic squares on this one, so I'll kind of draw over here. Magic squares, Captain Dan. Now be careful with your negatives. All right, so negative x times negative x squared. Negative 3 times negative x is 3x. Down here we get 3x, and we get 9. So all of this becomes x squared plus 6x plus 9. Okay? All right, so this, there. They're all the same. All right, I'm going to just rewrite all of this. I never like to do too much in one step. All right, let's do the distributive property here in my next step. So x squared plus 6x plus 9 plus 5x plus 15 plus 2. All right, combine like terms and write it in proper notation. So g of x, you got an x squared there. 6x, 5x is 11x. And then I got 9 plus 15, which is 24, plus 2, which is 26. And there is your transformed function, which looks really different than this one. But think about what we did. We moved it 3 to the right, we moved it 2 up, and we reflected it over the y-axis. Okay. If you want to, go ahead and graph these and see if you can see that transformation. Okay, let's stop there. We'll cover the other examples. These will be covered tomorrow in class.